Hi students, and welcome to another video lecture on logic design. In this video we will continue to learn about the SR latch. A few points to recollect from the previous video on the SR latch is that it is the simplest latch. It has two inputs S and R and two outputs Q and Q bar. S stands for set and R stands for reset. When Q is equal to 1, the latch is said to be in a high state, and when Q is equal to 0, the latch is said to be in a low state. We have also learned how to draw the block diagram for an SR latch. Remember that in a latch there is no clock signal. We also saw how to write the truth table for an SR latch. In fact, we learned how to write two truth tables, the short one and the long one. Referring to the short truth table, we know that the first row says that if S and R are both 0, then the status of the latch reads as no change in the output. The second row says that if S is 0 and R is 1, then the status of the latch is reset. Remember here that reset state means that the output of the circuit is always 0. The third row says that if S is 1 and R is 0, then the status of the latch is said to be set. Remember that the set state means that the output of the circuit is always 1. And finally, the last row reads that if S is equal to R is equal to 1, then the status of the latch is invalid. And by now you know that an invalid state will always be represented as a don't care. Also, based on this short truth table, we wrote and derived the long truth table. A thing to remember about the long truth table is that the first column is S, the second column is R, the third column is labeled Qn. Qn is nothing but the state of the latch before giving any inputs to the circuit. In fact, you can call it as the previous output of the latch. The fourth column is Qn plus 1. Qn plus 1 is nothing but the state of the latch after giving inputs to the circuit. In fact, you can call it as the new output of the latch. If you have still not understood how to write this truth table, then I would request you to go and watch the previous video on SR latch before proceeding with this video. Now remember, the concept of digital logic that we are most comfortable with is the active high logic, where 1 indicates a high voltage or on state or set state, and 0 indicates a low voltage or off state or reset state. The circuit which we are about to study represents an active high SR latch. This is what an SR latch looks like. Notice that the circuit is made up of two cross-coupled NOR gates. Now you already know that logic gates cannot store any data. But when logic gates are cross-coupled in this way, the circuit manages to store just one bit of data. To help us analyze this diagram, we will require the SR latch truth table. We will refer to the short truth table here since we don't have much space, and the truth table for the NOR gate. Now imagine this scenario. If the previous output of the circuit is Q is equal to 0 and Q bar is equal to 1. I will use green color to indicate the previous output of the circuit. What will happen to the circuit if I now give inputs as R is equal to 1 and S is equal to 0? I am using blue color to indicate inputs. Now the first NOR gate will have inputs as 1 and 1. Since the gates are cross coupled, that is, the output of one gate becomes the input of another gate. Now this 1 and 1 given as input to the NOR gate will give you a new output of 0. I have indicated the new output in purple color. Now the second NOR gate gets as its input 0 and 0. Now this 0 and 0 given as input to the NOR gate will give you an output of 1. I have indicated the new output in purple color. In fact, looking at the long truth table, we have just implemented the following state. The previous state of the latch, that is Qn, is equal to 0, and you have given inputs S is equal to 0 and R is equal to 1. Therefore, the new output Qn plus 1 will remain as 0. Let us take another scenario. What if the previous output Q is 1 and Q bar is 0? What will happen if I give inputs to the circuit as R is equal to 1 and S is equal to 0? Now the first NOR gate will get as its inputs 1 and 0 since the gates are cross coupled. 1 and 0 given as inputs to a NOR gate will give you a new output as 0. In contrast, the second NOR gate will get as its inputs 0 and 0. Again, since the gates are cross coupled. Now 0 and 0 given as inputs to a NOR gate will give you a new output as 1. In fact, looking at the long truth table, you can say that we have just implemented the following state, where the previous state of the latch, that is Qn, is equal to 1, and you have given inputs S is equal to 0 and R is equal to 1, thus changing the new output Qn plus 1 to 0. In the same way, you can prove all the remaining entries of the truth table with the circuit diagram. That's all for now. Connect to the classroom for more videos and study material.